Mohamad Abed from Syria, PhD student in EEE, Electrical and Electronic Engineering. 5 years experience in mobile telecom company as a power design engineer. Now I will present a small video about talking about designing and implementation of a grid photovoltaic system with a dual axis tracking system using microcontroller to increase the efficiency of the PV panels. So please play. Start talking. There's an issue. I don't know why. The guys there don't know about this video. So we will concentrate on the mechanical part, dual axis tracking. So it's the first idea. But unfortunately, there's something wrong with the guys there. It's not working. System using a microcontroller to increase the efficiency of the PV panels, PV systems. So this is the whole project. So, and we will concentrate in this part. This is mechanical part. So this is the mechanical section of the system and the explanation of the work mechanism. The first part is the mechanical part, consisting of the following PV panel gearbox. It consists of 2 gears and 2 DC motors, prop and base. This part is designed to ensure the strongest tracking for the direction left, right, up and down. So this is wired. So the sensor here, LDR for LDRs is wired, as you see. So this is the control circuit, a microcontroller, PIC 16F877A was used in the additional for 4 sensors, LDRs installed at the top of PV panel, as shown in the figure. So this is just program simulation, okay? So now, after we simulate and we implement the circuit in the right, this is the algorithm used in the controller. So now we will see this video and ensure that the system is working now. The system now is tracking the strongest light toward the 3 lamps here. Okay. So the strongest ray or radiation will be directly go to the surface of the panel. So to get the most, this is easy to get the most power, the greatest power. So it will now go toward to the window. You can see and stop because we turn off the lamps or the output of the inverter. So now we will do this this again and again to make sure that it's working. Now this is tracking system, dual tracking system. After that, we will get the output curves for pre-generation and for 3 months, and we compare with 3 curves with axis, with tracking, with a fixed engine, with mist tracking for 3 months. Now we will see I'm doing a flash mobile light to ensure that it's tracking for all direction, okay? And you can see the mechanism. It's very simple. We can do it. It's nothing impossible, So it will generate the maximum power point tracking. After that, the question is why? How can I get these curves of the output of this system? For example, I will put this system in the work output, in the out of the sun and rain and like something like this, and I want to get the curves. How can I get the curves? This is the output curves for 3 months, as I told you. This is the blue one is with the tracking, the black one is without the tracking, fixed engine, and the red one is mist tracking. So I have to get these curves. How can I get this curve? There's 2 ways: by manual using climb meter and calculating power, output power, or using something special, solar advanced data logger. Solar data logger, alternative energy data logger. So I make advanced solar data logger. This is advanced solar data logger. We can get all this. This is 5 current sensor and 5 voltage sensor, and 2 humidity and temperature sensors. We get all this is the temperature and 2 DH21, sensor for the battery and for this is a solar irradiation sensor, pyrometer. We call it. This is the components of the project, second one. We got all these parameters and we recorded in SD card here. So after that, we choose the sample time for 1 minute, for 5 seconds, for 1 hour. And I use Arduino Mega controller. So this part of the research is very important and very unique. So I can see here by the photos, this is the main interface of this display, the time and date, the system, the type of system, voltage of the system, store time, and this is resetting sensor. We can resetting on also sensors. This is the display temperature of the PV panel, humidity of the PV panel, temperature of the battery and humidity of the battery, V and I for battery and load and battery and solar PV panel, spare BSH peaks and hours. Is that we can measure the solar irradiation. So, like you see, power, it will be calculate the power after parameters, and after that, he will store it in the SD card. After store this in the SD cards, there is interface C# on the laptop. We will get this value to the laptop, and it will be as a table, Excel table. We will draw the curves of the output of the system. Okay, so we will analyze these curves, and we know if this system is enhanced and evaluate the system performance. So we can evaluate the system performance. In addition, this project, the second one, is not only monitoring, it's also taking action by the relay board, consists of 8 relay. We can adjust a reference value for PV. This is output, by the way. This is output values. So we can adjust a reference value for irradiation, for temperature of battery, for temperature of PV panel, and make this reference as we protect it from a high voltage, from a low irradiation. So here is some video if you want I will share with you how it's work. Okay. So I think the idea is clear. If any question, I am ready. This is video for the operation of the project. Second one.